Okay, so now for example number 7 out of your textbook. In example number 7, they have the population of a little city known as San Jose. Okay? And so the data that they've collected is the year and the population. So in 1990, they had 782,248 people, roughly. And in the year 2000, they had 895,193 people. Now, why would they need to know this information? Why would you want to know or track how many people are going to be living in San Jose in 2015, 2020? How would that be helpful to the city of San Jose? Well, they take care of the people, so they need to know how much garbage they're going to take out. They need to know how much water is going to be used. They need to know all those factors of running a city are based on how many people they have. So you can very somewhat easily predict or get a good approximation of how many people are going to be in the city. One way to do that is it's an exponential growth, right? Because basically what happens is kids grow up, they get married, and they have a couple of kids. Now some families will have 2, 3, 4 kids. So there's a number out there if you average how many kids are born per family. Now some families don't have any kids. Some families have 7 kids. All right, but overall there's an average, so over time their population grows, right? And, unfortunately some people pass away too. So that number can be modeled with exponential growth. And so what we want to do is we want to figure out what this means. Now, if I translate this, whatever P of t is, it's going to have to look like a times b raised to the t. That's an exponential. So when P of, do we want to call this 0 or do we want to call it 1990? It doesn't matter. Mathematically, it still should sort of work out. So we could think of this as 0, and if I make that 0, what would the year 2000 be? 10 years later, right? Now, it doesn't matter. You just have to remember how it translates. Because we're going to get some time, but your functions will look different. So I'm going to stick to the book. And they said that P of 0 was equal to 782,248. They said that P of 10 was equal to 895,193. Okay? So that's the first step, is figuring out what those values are. Now we know that this takes place over a period of 10 years. Okay? Now one method that we could use is if I take this function, if I take this information, really what I'm saying is P of 0 was equal to 782,248 times b raised to the 0. If I consider that the initial condition, right? Now, another thing I could consider is that p to the 10 should be this initial condition, which is 782,000, comma, 248 b raised to the 10. You guys with me so far? We're almost done. Does that make sense? Well, now, if that's the case, I happen to know that that is equal to 895,193 is equal to 782, comma, 248 times b to the 10. So my goal, what am I trying to figure out at this point? B, because that's all I need. I know what my initial condition is, which is the y-intercept. That's why we've been talking about the y-intercept. That's the initial condition. And then what I need to do is figure out what b is, right? Because my goal is I want y equals a times b raised to the x. Well, I know what a is. I don't know what b is yet. So what I'm going to do is I'm going to divide both sides by 782,248. This side cancels, and I get this number over this number is equal to b to the 10. Well, how would I get rid of b to the 10? I could take the 10th root of both sides. The 10th root, Mr. Adams, that looks kind of complicated. Well, it is. So now how do I find a number value? What is the 10th root of all that stuff? Well, I have to go to my calculator for that. So I'm going to hit second quit. Now this is one of those deals where you got to make sure you put it in your calculator right. I can take the 10th root, but the 10th root of something, isn't that the same as raising it to the 1 over 10? So that's what I'm going to do. Well, what is that something? Well, that something is 895,143 divided by 782,248, close the parentheses, and raise that to 1 divided by 10. So, see how I put it in the calculator? Looks completely different than what I've written on the board. Okay? So now what I'm going to do is I'm going to hit enter, and I should get like 1.01. What that means is that b is approximately 1.01. Well, then what would my equation of the line be? What would my graph be? What would my function be that models this behavior? Well, my graph should be, or my function or equation of the line should be a, which was 782,248, times b, which is 1.01 raised to the x. Now I can verify that in my calculator by going into my stat list, and I'm going to clear my list first. Oh, it doesn't like that. So let's just go in here and clear it manually. I don't know what I entered in here last. All right, so I've got two numbers to enter in. Those two numbers are, we got to go way back up to the top. I'm going to enter in 0 and 10. And then I'm going to do 782, 248, and then 895, 193. And then I'm going to go to Y, clear out my graphs. And then I'm going to turn my stat plot on. And then lastly, I'm going to zoom to my zoom stat. So those are the 2 points. Now this is an exponential regression, so lastly I'm going to hit second stat, stat, not second stat, go to calculate, and I want an exponential regression. Not a power regression, an exponential regression. So I could store it and graph it, I just want to calculate it. There it is. Is that what we have? Does that make sense? Do you need to know how to do it by hand? Yes. Yes, you do. Is it good to know how to do it on your calculator? Yes. Yes, it is. Okay. Any questions from you guys, though? Okay. Problem number 8 is very similar to number 7. It's the exact same problem, just different data.